It is really overwhelming to see this room full of people. The agricultural rooms have been full during the last 4 or 5 congresses. We are always asking for more space, so this doesn't happen. So, well, very nice conversation with the working group. I don't want to lose much time, but I would like to introduce the different speakers. I'm going to read so that everything is there. Fernando Latanzi is going to start with his presentation. He graduated with a degree in agricultural engineering and completed a master's degree in animal production in '98. Both cases from the National University of Mar del Plata. He completed his PhD in Munich, in Germany, in 2004. Since 2016, 15, he has been working in Uruguay. He lives in Colonia. His work has focused on the physiology, ecology, and agronomy of forage plants, using sustainability of grazing systems, analyzing inclusion of irrigation in this type of dairy systems. Then we will have Juan Insua's presentation. He is an engineer, professor at the National University of Mar del Plata, agricultural and engineer, researcher at CONICET, co-founder of Pastech. He holds a master's degree in animal production and a PhD in agricultural sciences in Balcarce as well. His current work focuses on the development of technologies and practices with high environmental productivity that include animal nutrition and grazing management for meat and milk production in pastoral livestock systems. Fernando, let's start with you. And we invite you, as Fernando and Juan make progress, that you can think of suggestions, ideas to have a very nice exchange during the last or the coming 10, 15 minutes. So, good afternoon. It's amazing that the room is so full. So we have this presentation. I'm going to talk about the dairy system. And last year we have been working more in livestock systems, in precision livestock, and the experience comes from dairy systems. And the subtitle is trying to focus on which are the data that you want to monitor, add, and which are the markers that you need to use for grazing systems. So before I start, I would like to have a brief introduction of our working team. Nico Baraybar, I still work with him. He's in charge of developing the implementation and validation part of many of the tools. Lucia Betancor, Santiago Fariña, and Diego Giorello. They have been really important for many of the things I'm going to introduce. We have been working in Argentina with Germán Verone from INTA Balcarce and Martín Durante from INTA Concepción. And my special recognition to Monica Angus Day, INTA Balcarce, and Arturo Mansanti. Also important are the sponsors. INIA, Uruguay, and INTA Argentina pay our salary. We have also very important sources of financing during the last 2 years of development. And MPI of New Zealand, it's a global methane hub. They are supporting us for transfers and validation of tools at field level. So grass stock is the average of biomass of a grazing platform. And if each of the arrows that you can see here is a place for horses, stock is the average covered. So in principle is that when we talk about grass stock, is the amount of surface that you have available. And this is for all the open fields and the places where animals can graze. For fallow, implementation, and the rest is the grazing field. Before we talk about this, I would like to talk about precision. Precision in what? This is the magnitude of the variation of the optimal animal charge of a grazing system. So what I'm showing you now, this has been prepared by Rodriguez Palma in a natural field, how we call a natural grazing field, that is very stable, has 40 species per square meters, there is no irrigation. But look at the variation in loading that this site has to have in order to have a stable stock between 9 and 13 centimeters. Each one of these lines is a year of data, and even in the stable part that you can say June, July, August, you can be between 200, 300 kilos of material. So this is Stuka, the previous year in Balcarce. These are two crops. We don't have two springs with the same amount of load, and they start at the same time. And this is Rairas in the south of Brazil. These are 15 years of data. One of these points is a parcel that was maintained. And look at the magnitude of the load that was necessary to have that parcel at that height in different times, different years. In essence, grazing management make loading adjustments. All these variations that I showed you for animal load is what you need to have behind to have your grazing platform stable. And the scale is very short, 1 week, 2 weeks. That is the magnitude of the change that we must manage. What is stock? Stock is a variable. When we define a range of objective stock, I want my system between 900 and 1,100, so that is the marker that we can adjust or try to convince them that it's very useful to guide yourself in the different decisions. Why do we have so much variation? What I'm showing you now is the foliage elongation rate in the chart that you can see upwards. This is a 1 week of data. The shadow is night, the rest is day. Look how much time a plant takes to realize that the temperature has changed. A few seconds. And on top of that, at least in Uruguay, this is Estanzuela, where I work nearby Colonia, all throughout the year, we have a sequence of stresses. So now, for instance, we are in winter, 1-2 millimeters per day, we have hypoxia with a lot of variation. When October comes, mud goes away, we have 15 good days, and then we have hydric deficit until the end of February. In the middle, we have 1, 2, 3 weeks of temperatures that are above normal, that a template plant can sustain, support. And then in April, we have 20 days that are very good, very nice, and then we have mud again. So the forage plants very fast response to the variations in temperature, and we have a lot of variability in all the factors generating stress, and if the answer is very good and very variable. So that is the reason why we have so much variation in optimal load. Do you know this phrase?
A ver quién es ese señor, pero fue un señor que dijo una frase muy famosa, o copió de Galán: manejo del pastoreo, variación.
Variation, temporal variation kills spatial heterogeneity. When we have talks about management of crops, always the focus is on different environments. These I'm going to do different. In agriculture, grazing systems, what you're fighting for is the temporary variation that is more relevant in grazing management than the spatial variation. I'm going to focus. I couldn't come up with a figure, but I would like to mention this. The way we harvest grass in a grazing system, the frequency and the intensity we graze affects the yield of that system. And that is a concept that is really related to grazing systems. With soy, the harvest time is 1, you can have some loss, but it doesn't define the yield. But when you make a grazing decision, you are accepting how much you're going to harvest. And then you have 6, 8, 9 grazing decisions to make during that year. So that's where the challenge lays, the temporary variation and the number of decisions you're going to take so that that system works well. And the other issue is that it affects the yield and how the animal makes that or turns that into a product. So something that I would like to leave you with is when you think about a live weight decisions, animal load per input, the same you can express in terms of how much biomass was harvested and which level of efficiency. So these two results are the same. Load and yield can vary. I can change the load, I can change the yield aim. But our purpose is how much I want to harvest and with which level of efficiency. Load and yield are two tools. Our goal has to be how many kilos I want to harvest of grass and with which level of efficiency I'm going to use it. So you know that there is an optimal time. If it's very early, the plant is weakened, or I lose production. The way to realize this, in which part of the curve you are, is the number of leaves, how a certain species has a certain number, maximum number of leaves. If you have more than that, you are not there in the optimal moment. The most important part is how the animal faces this situation. Probably you all know it, but I'm going to refresh the information. When the animal is about to graze, it's not doing it in any way. It's in status. It's in different levels. It doesn't matter how much biomass or how much species. The first layer is 50%. 10. The second one, 50 of what was left, so 5. The third one, 2.5. And this, that looks like a very easy calculation, I'm going to copy Marcelo Benvenuti, a series of pictures that he took with a camera. Look, a dairy cow. It's a very good grass mopper. So he was able to record, look, horizon number 1, horizon number 2, horizon number 3. So you are saying to the animal what type of bite he or she is going to take. So this person contributed a lot of information. The time it takes an animal to do all this, to eat, varies. That bite from 200 grams to 600, but 0.7 seconds, which is to open and close its mouth. So when you want to harvest 6 kilos of dry matter and you give a big bite of 0.3, then it takes you 6 hours of grazing, 250 kilos. If the bite, you said, okay, take horizon 1, big bites. If you say, take also horizon 2, so your bite now is 0.1, 100 milligrams, is 15 hours of grazing, not 15 hours in the field, 15 hours with their head down, opening and closing its mouth. So at the moment of defining how many horizons you take, you also define how many bites it's going to make and how much time that animal needs. So if you have 1 or 2 horizons, what you're actually defining is the consumption capacity. So when you have to define at which point of the curve you enter and how many horizons you take, you are deciding how much you're going to harvest and with which efficiency. Because if you eat 4 or 5 kilos, if that animal is 300 kilos, then you're gaining an amount, and that's where the efficiency lays, in how many horizons you take. So this is what you have to face when you manage grazing systems. You have a collection of parcels in different parts of the curve, and you need to go in and out of all the parcels. I enter, I go out. When I finish, or when I leave the last one, it has to be in its correct point. There's no way that you can exactly enter that curve without changing anything. So what is stock is the average of all those biomass. And why is useful? Because if you are entering early, using it, depleting it, and having an average, you have a low stock. If you enter well, you end up well, and then you have 3 parcels that are ready to be used, you have a very big stock, the average of all the parcels. So the stock, and knowing whether the last 3-4 weeks you are going up or down in stock, then you know what is.
Hi, everyone. Huge crowd. Let's see how this goes. I hope my presentation is useful. And I'm going to try and continue with what Fernando said. Fernando was telling us about how important it is for us to know the amount of grass that we have in our lands. And the idea today is to talk about this. I don't know whether if these are new technologies, but at least progress in the technologies that we have, to know how much grass we have and how much grass we are producing. I just want to mention now how important it is for us to know this that Fernando explained, knowing how much grass we have, how many kilos of dry matter we have per hectare. And why do we want to know this? Well, because with this information, farmers can make practical decisions. And if we know how much grass we have in each area of our farm, we can know how much grass are there when animals come in, when they leave. We can calculate the apparent consumption. If we measure frequently, we can calculate how much grass our field is producing, what is the growth rate, how much grass we want our animals to eat, how much time they can spend here in these lands, the number of animals, and also we can do what Fernando showed, a ranking of lands, of plots, to decide where to send the animals to eat. And then to budget, like at this time of the year, I won't have enough grass, so I need to buy these supplements, or I'm having too much growth, and I need to close some plots. So for this and for many other purposes, it is important to know how much grass we have. And in my opinion, I would say that it is crazy to know that more than 90% of farmers at the global level do not measure the grass. And grass is the most important food. And food is the most variable cost in animal production systems. So if we can make grass turn into meat or milk, our systems will be more profitable. That's how we say that we need to know how much of our main resource we have, which is grass, especially in our pasture systems. And before starting, I would like to say the following to give you some context. This system that allows me to measure how much grass I have and how much I'm producing, is this good or bad? Well, to give numbers, there are works that say that a great grass or pasture measurements must be measured frequently, once a week or once every 15 days. And the data shall be available 24 hours after measuring it. I cannot have it the next week because it will be too late. And the estimate shall have an error below 150 kilos. And in practice, I would say that a measurement shall have an acceptable error for decision making of plus minus 300 kilos of grass per hectare. This is a field in Tandil. We measure there with the pasture measurement device. There are 400 hectares here. And it takes 3 hours to go through the 9 kilometers. And we have to go there. It doesn't matter if it's cold, if it's hot, if we are going to be spending fuel. The truth is that pasture measurement is very important. And this is why we know that many farmers do not measure it, because it is expensive. And I would say that all the methods that I'm going to include, the pasturometer, the plate measuring the compressed height, is one of the most important methods. It's the gold standard for the scientific community. So I would say that the pasturometer is the most important element for this. But all the methodologies that we mentioned, if they are used the right way, they can work too. So now, imagine what I was showing in this field, that it was taking us 3 hours to go through it. By using satellite estimations, and this is already proven, we know that a well-calibrated satellite can give us estimates with acceptable errors. So what is the main difference here? We do this from home just by clicking. If the tool is calibrated, we can obtain those values that stock there at the field. But what we always say is that the tool shall be calibrated for the field. So remote sensors, drones, satellites, gather information in a field, then it generates maps with different types of information and indexes, and those indexes, through AI models, etc., become yield maps, pasture stock maps. And what I will show after are works using these methodologies in different projects in which we've worked in the past 10 years, including projects in the US, in Michigan University, with Fontagro, in Uruguay, and now working with Australian projects. And also I'm going to be showing real data from companies with real plots of land. And the work shows that any methodology, whether a pasturometer, a ruler, or a sensor measuring the green index, all of them, if they are well calibrated, can have an acceptable error for the quantity of grass. With regards to the green index, this graph on the right showing the relationship between NDVI and kilograms of pasture, we see there more variation than the height measurement. And the NDVI, the green index, is the most used, but it's not the only one. And it comes from sensors obtaining spectral information at different wavelengths, and then an index is calculated. But there are many. NDVI is the most used, and I will show some data about this. So this was work done by Selena for her PhD, and she's comparing here the handheld sensor and the same index but with a drone. And what I want to highlight here is that beyond the goals of the work, The green index measured by a handheld sensor and the drone showed the same precision, okay, the same accuracy. The main difference between both methods is that with the drone, there's a larger sample intensity. In fact, the map is given us by the drone. However, even though the handheld sensor is accurate, it depends on the path I'm taking. And by the end of the day, the drone ends up being more accurate than a handheld sensor because it will gather all the heterogeneity, which is the main issue when measuring pasture. In that same PhD thesis, they were comparing the green index with a drone in different species throughout different years. And what we can say here is that there are no differences comparing years. If I'm comparing today, August 6th, a drone, I would expect for it to work on August 6th next year, okay? Also, different fertilizer doses were measured, and we can see how in common used doses NDVI is not relevantly affected, so we do not need any calibration whatsoever. I mean, I'm going to calibrate a drone or a satellite for a specific area, and this is how we do it. But with a satellite, assessing the NDVI in different species and stations or seasons, we see a difference here. It's like calibrating a plate. It's not the same, the compressed height in the spring that in the fall, okay? So this is very similar. We need to calibrate the drone or satellite using NDVI for the different seasons of the year. This is an image from a drone at Intabalcarce dairy farm. This is a picture taken by the drone camera showing how it looks, the area after the pasturing, the area where the pasturing is happening, and the area where they're going to be pasturing tomorrow. So we could just say there are not many differences there, but after processing the drone images, we can clearly see the differences. This is NDVI, so NDVI will grasp those differences, at least in the biomass ranges that we usually have for pasturing, right? So here I will contrast something. The image with the Sentinel satellite. One of the main differences between satellite and drone is resolution. Drone can measure every 2 centimeters, and Sentinel can measure every 10 centimeters. However, I believe that the satellite pixel for 10 meters works quite well for intensive systems such as a dairy farm with small plots. Also, clouds are important to distinguish drones from satellites. Drones are flying below the clouds. And here we have the NDVI measured by a drone and NDVI measured by Sentinel satellite. And you might believe that there is no relation here, but we see that each color is a different date. And these seemed like sunny days, but I don't know if you can see to the top left, there's a red square. Well, that's where the field was located. And those 2 dates, it is cloudy there. So these pieces of data that are leaving the curve are actually because it was a cloudy day, and clouds were impacting the NDVI. Therefore, NDVI is affected by clouds, and that is an important difference with drones. So if we extract the cloudy days, here we see a very straight relationship as in sensor and drone.
So going back to the previous graph between the relationship, this one shows the relationship between NDVI, satellite, and biomass. And if we remove these two cloudy dates, the relationship is good or with an acceptable amount of error. So again, the clouds diminish the NDVI, and you need to be careful when you gather all the data with satellites. Well, advances in sensors, whether these are remote sensors, drones, or satellites. So what enables us is to gather a lot of spectral information, and with that, to calculate many spectral indexes. So we can gather a lot of info, and artificial intelligence really, or machine learning really plays a role here, because in a gross manner, instead of calculating or calibrating for each situation, for each field, for each station or season of the year, another index or the NDVI, now I give this information to these models and I say, okay, can you be in charge of calibrating this continuously? So what I do, I provide you data so that you can learn, you can train, and you can start to predict and understand with behaviors and estimate the amount of grass with a lot of information. Honestly, in the scientific community, this has been under study, and we are working a lot on this. There's a very big amount of work in this sense, and what we can see about reading the reviews is that these artificial intelligence methods, there are many models, and some people choose ones and other people choose others. But the important thing is that the accuracy doesn't change much about whether I choose one model or another one. So what impacts the most the accuracy of estimates is the number of variables that I give the model so that it can start with its estimations. The variables that I choose for the model to estimate. So also another thing important is the amount of data that I provide the model with so it can learn. So if I go more to the field and I measure and I tell the model, look, at this time and this piece, I got this amount of grass in this parcel, the more information I give, the more the system learns and the best the adjustments are made. And then for reviews, there is something I would like to highlight, is that for conclusions, there's a big amount of work, but there's also scarcity of work that really assess how precision or accuracy plays a part in the estimates. So we are lacking comparisons, and for instance, we have this amount of grass in this parcel, and many people go there and compare whether that estimate is correct or not. So I'm going to show you now some data from companies that provide the service where that was evaluated, that was assessed. They went there and they measured it. So they went to see how it works. These are data from Uruguay where they compare the prediction with the satellite and the visual estimate. It's not the ideal, but a trained eye can have a very good prediction or estimate. And truth is that the relationship, this shows a one-to-one. If the points are near the one line, the most accurate it is. So you can see with this accuracy an error of less of 184 with a satellite. You can follow the production in time of that parcel. And if we do it of the entire field, we will have stock of the entire field. And if we do it frequently, we are going to have the growth rate. So I can show you more in Uruguay with the measurements seen with the pasture meters, in Castelli, in Tandil. Some of these works calibrate the satellite for the producer, and others are without calibrating, without giving measured data to the model so it can learn. And they have worked very well and predicted very well with a high level of accuracy. However, this is the complete set of data. The average, I say it's acceptable, but there are times where the error is significant. Then you need to calibrate the satellites to diminish the level of or the amount of mistakes. This has been done by an Australian company, 500 kilos without calibrating, the machine learning and the satellite without calibrating. The error is 500 kilos, around 500 kilos. The estimates are not good, they are not accurate, but this work compared the model with different levels of training. So this is without giving the model data that had been measured. So what we found there is that as you started to feed the system with measured data, predictions became better and better. And the conclusion was that for that company to measure 5 parcels in your field or in that field every 15 days and to give that information to the model enabled the model to diminish the amount of errors to a reasonable level of 300 kilos. So the message is it is important to evaluate these tools to see first if they are predicting with error or not, and to use that data to calibrate the tools, because it's also possible that they are not accurate. But this is another work that compares different methodologies, estimates of biomass with rules, with SIACs, with drones. And the reality is that any methodology that is well calibrated works or provides accurate estimates, but you need to calibrate it. Another thing that I didn't mention so far are the simulation models. Simulation models, dependent on climate, are used not only to estimate a grass stock or kilos of pasture, but growth factor, growth rate. They take information and they predict how much the grass is going to grow. These are data for an actual field. You can see the continuous line. That is the prediction. And the prediction are quite good. So there are platforms nowadays that what they do is to integrate these 2 factors that I just mentioned, because the remote sensors that I mentioned today, satellites, drones, or estimates, they give us a picture of the status, today's picture, how much pasture in each parcel. But on remote sensors, they work quite well. But now we have another variation, what Fernando said, the spatial variation. So if we have models that are calibrated, they can copy quite well this spatial variation, integrating with the remote sensors. So that integration of the different methodologies improve the prediction in terms of space and time when you measure grass, and the most precise they are, the better it is concerning grass, etc., etc. Final remark. new advances in technology can make grazing management objective, accurate, and easy. But at a certain moment, I want to say that we are going to go to the field and see how this tool works. That's all.
Bueno, ahora unas reflexiones para prepararnos, para ordenar las preguntas para Juan y para Fernando.
So the question for Andy, Luciano. I'm going to be creative now, something that is very difficult. So, time to relax so that you can add any question. We have a few already. So what happened, livestock is very multifactorial, and it depends on many factors. That is a reality. That amount of information generated with a clear objective of excellence by INTA representative, IGNA representative, and many institutes, research institutes that we have in our country, in Argentina. And as I was saying before, you understand that the goal lays within you, women and men of 20, 24, 19, because Juan said it is crazy not to measure grass. Everything that has a very important amount of detail. I started to read about this during my career. Fernando, Juan also train, and they are in charge of technology with a lot of knowledge. So when you all this translated into numbers, because the idea is to generate richness and that this ends the best possible way. So when you put numbers trying to optimize pasture production, that it's not marginal, 2,000 to 4,000 of dry matter, with an agricultural field in rotation in the core area, that is a challenge to talk about. It's a lot of money at stake to improve the production. So pressure, in the good sense of the word, and even though it is difficult to follow their presentation with so much technical details, professional knowledge, the presentations were excellent, but they're going to become passionate, and they are going to have a level of protagonism that is key. There's a lot of money involved of unproduced richness that is in your hands at the moment. In the middle, it's us and the ones that continue. So I'm going to read. I think there are one or two questions with that are not so specific. The ones that are more specific, I apologize, I'm not going to read it. You can approach Juan. And I want to conclude also this talk talking about the private-public interaction while we are in initial stages. It is crazy not to measure what Pablo was saying or what Fernando says, all the knowledge that we have, it is real, why we need to stock, and we need to train ourselves as professionals, and the business person need to request things from us. So the most important thing are the glasses, as I said before. The question is, in the north, in natural pastures, they have same level, same value. In the north, natural pastures, in the same grazing area, paspalum, luciola, and other non-consumable cutters, renewables, peraceas, and others. Juan, can you give us a very concrete answer? And then we can move on to the more conceptual part. Sensors, do they make the difference? So with the data that I have to show you, I would say no. Amount of grass in total, even more if you use a green index. At the end of the day, it tells you how green is what lays on the bottom. So the greener, the more pasture there is. But there are many factors that play a role that alter those estimates. So is it possible that someone is working on trying to differentiate, but to measure pasture and to differentiate species? Some work estimate quality, protein. Perhaps Fernando knows more. No. At species level, probably I'm not going to see it, but in terms of components, percentage of protein, and digestibility of the fiber, this can be parameters that can be estimated remotely. In natural pastures, it is controlled how much green you have, and the sensor is good at telling you how much green there is. So digestibility, protein, I haven't seen anything that is super convincing. Thank you very much, Juan and Fernando. There's a comment or a question, point of view that says it's very good to measure. The idea is to be able to optimize and calibrate the production of kilos of meat with pasture and the cost of transaction of adjusting the load. So in a way, Christian is asking to adjust the load is to buy, to sell with effects in rumen. So with the load adjustment is very good, actually. In dairy systems that are very complex, the grazing management is very simple. You always have another source. You have silos, you have concentrates, or forage system. If I have a pasture, surplus of pasture, I can close the reservation or the opposite system. In livestock, it's different. The basis is the same, but other definitions. It is more heterogeneous depending on which livestock system you are using. Reservations are a part, and people say, okay, I don't have machinery for reservations. The same happens with supplement. In the field, you also always have another element. In livestock, whether you supplement or not, in 2-3 months, you work in a different process. So what I would like to do, first is going to be more difficult with the dairy system. What is the added value? Is to give you an idea, a quantitative idea of what this decision implies. And then any system will sell and buy, another one will make reservations, or another rearing parcel. But let's say that you get 15% surplus of pasture, so that you know the magnitude of the loading adjustment where you are involved. And the second part is, and I repeat again, the frequency of the decisions that you make. Many times, a lack of opportunities earned because you were distracted for 3 weeks. If this happens in September, you go from something that was spectacular to a problem. So we are talking about only 3 to 4 weeks. And many grazing conditions are defined there. So livestock decisions are more difficult, more complex, and they have only one advantage compared to dairy systems. In dairy systems or industry, you're never going to convince the producer. If you don't have grass, then you need to produce less. In livestock, you have that available. You can say, okay, I wait 2 months and then I complement. So my decision, my idea is that depending on the result you got. It's forensic. You have an autopsy after a few months and see how it went. Thank you, Fernando. So we are very neat, and so we need to conclude this presentation. I would like to take 15 to 20 seconds because of the commitment of participating here, the relevance of the public-private interaction. I would sum it up saying businessmen, there is a lack of protagonism that is quite significant because we have workshops with companies already for many years, líneas, but the one that is static in general terms is the business person in understanding the lack of gain involved, and then I will go to the schools so that they know that they are trained and highly motivated and passionate to sell their profession, to sell their services. So protagonism, to give that step, is to consolidate both aspects. This is my point of view. I hope I motivated you. The future of the profession. Fernando, you can say or you can contribute something else. I think you as users should be interacting with private partners. Public are very bad at the interaction with the customers. I'm not thinking how I can implement an interface that it's easy to use. I'm only interested in the system that lays behind. So to have a channel, a feedback channel with the private sector, and for us, the challenge for the public part is how we can be still relevant. This is an extreme example. Someone that comes, pays my salary, and says, you from India, what are you doing? All the private ones are telling me how much pasture I have. You shouldn't be in charge of that. So if that feedback is not there, then it's easy to get into that trap, something that was necessary to get to the front end. So again, thank you very much. Thank you for your presence.